blast off. So now we're going to solve. Now we're going to solve a quadratic equation by graphing. And you know, if you have like a standardized test, like say you're taking the SOL and it says solve this quadratic equation, they can't really tell you how to do it. I mean, if you find this method to be better than factoring, then by all means you use this method. Okay. And there's some important concepts that come up in this, other than just the how do you put this in the calculator and graph it and solve it. So, the standard form of a quadratic, if it's an expression, that means that there's no equal sign. It's just ax squared plus bx plus c. A, b, and c are real numbers of some kind. The only thing you know for sure is that the a can't be 0, because what would happen if a is 0? There is no x squared. Right? So if it's a quadratic, it's got an x squared. Right? If it's an equation, then it has to be equal to 0. If it's a function, then it has to be equal to y. Right? So what can we do with an equation? What do we usually do with equations? What do the directions usually say? Solve. So you solve. Solve. Okay. Expressions usually use simplify. And for us, simplifying could mean factor. Right? At this point, it probably means factor. Simplify or factor. Now, even though there's an equal sign in the y equals ax squared plus bx plus c, you can't solve that because it's got two variables. I mean, the a, b, and c are constants. We'll figure out what those are. They'll be like in the problem, like they are in all these problems we did. There's numbers in those places. But there's two variables. There's x and y. So we'll never be able to have just one value of x that solves this thing. Right? What we will be able to do is make a table of values, plug in a lot of values of x, and then for every one we solve for y, and we'll have a bunch of points. And then what do we do with all the points? We graph them, right? We graph them. So functions you graph, right? Up to now, the only function that we had graphed is linear. And what was the shape of a linear function? Straight line, right? That's a linear function. Okay, now we've got to see, well, what does the shape of a quadratic function look like? The quadratic function has the shape that, you know, most students, if they have to just like pick a word, you know, to describe, usually they can say it looks like a U, right? It looks like a U, which is fine, right? It's not precisely a U, but it kind of has that shape. If it's a quadratic function, then that either this thing is going to open up, or it could actually open down. It could actually go like this. It's got to do one or the other. Okay, the thing about this shape is it's completely symmetric, right? It's the same on one side as it is on the other, like mirror images, right? If you draw a line right through the middle of it, it should look like it's the same to the left as it is to the right. Okay, that line, which goes right through the middle, is called a line of symmetry. Actually, most of the books, they'll call it the axis of symmetry, but it's a line of symmetry. Next year in geometry, you learn about lines of symmetry. You know, we're only doing this to present the shape, to understand what shape it is. Do you have a question? Yeah. Okay. Right, the point of the vertex, you know, right there at the bottom, that's called the vertex. Okay, and of course, like any graph, it can have x-intercepts and it can have y-intercepts. If you notice this one in particular, you can see the y-intercept. Jonathan, pay attention, right? You could see the y-intercept, and you could see that it had two x-intercepts, right? Now, the parabola is actually kind of an interesting shape. Does anybody here have a satellite dish at home? Any satellite dishes? Satellite dishes are shaped like a parabola. because a parabola has this unique feature that anything that shines into the parabola will bounce off the side and be reflected to a point in the front. Right? Doesn't matter where it goes, it'll always reflect to the same point. Okay? That point is called the focus. And if you have a satellite antenna, it probably has like a thing sticking out in the middle like that. So the reason is because all the signal which is coming from space is hitting the back of that dish, and it's being concentrated because the shape is a parabola. It'll concentrate right there. So it's taking a weak signal and making it stronger, right? And if it's a bigger dish, well, then you should probably get a bit better signal because it's going to concentrate it more. Another shape that you might have, like the headlight of a car, right? The headlight of a car, and the back of it is a parabola. And it has, at the focus, it's got the light source, and then the light is shining in all directions, but every time it hits the back of the parabola, it shoots out straight to the front, right? And that's because it's a parabola. So it's a shape that, you know, we encounter in what we do every day. You may not realize it, but we do. Okay. So solving quadratic equations by graphing. Just a second. Here's the steps. If necessary, we're going to rearrange the equation so it has a 0 on one side. Okay. Now understand, we're solving an equation. I mean, it's 0 equals, right? It doesn't have a y yet. It just has a 0. So in this particular one, x squared minus 2x equals 3, because there's no 0 on one side, I need to do something. And in this case, it looks like I subtracted 3 from both sides, right? So now I've got x squared minus 2x minus 3 equals 0. Okay, now use your calculator. You got a calculator right there. Go to the y equals, right? The y equals is right here. Right? And put x squared minus 2x minus 3. Done? Okay, so you get it at that point. Then you hit graph. And you should see a parabola. That's what we expect a quadratic function to look like. So there it is. Okay, if your calculator has got something different in it, probably the best bet is clear your memory. And then start over. 2nd plus 7, 1, 2. 2nd plus 7, 1, 2. And start over. Now we'll be back in the middle. Because these calculators have been used for various things in the last few days. Clear the memory. 2nd plus 7, 1, 2. First clear the memory. Okay. Once you've got the memory clear, then you're putting in the calculator this. Just like it looks there on that screen. You go to y equals and you put x squared minus 2x minus 3.
I got it.
Okay, so we all should have a parabola that looks like this. Okay, now it says the x-intercepts of the graph are the solutions to your equation. So look at that graph right there. How many x-intercepts do you see? It looks like there's 2, right? There's one here, and there's one here. And you could kind of estimate what they are. What does it look like? It looks like that one is -1, and that one is 3. So the answers are x equals -1 and 3. Done. You need to know how to factor. Okay, there's things that we use that you need to know how to factor. And there are times, and we'll see it here, where you can't find the solution this way. So what possibly could be the situation where there would be no solution? Since we said the x-intercepts are the solutions, if there's no solutions, that means there's no x-intercepts, and that happens. Okay, that doesn't mean that there's no solutions. It means there's no real number solutions. The solutions are actually called imaginary numbers, and you do need to do the algebra to figure those out, because they may be called imaginary, again, according to Isaac Newton, but in the end, they're things we deal with in real life. So let's see. The second option you've got to solve is you could look at the table of values, right? If you can't estimate, what you see right there, the table of values is above graph. So you go second graph, and then look for where y equals 0. Okay, so you might have to scroll up to find the -1, right? But you can see definitely that -1, because y equals 0 here, that the answer is -1. And since y equals 0 here, the answer is 3. So x equals -1 and x equals 3. Okay. Now, that's great if your answers are integers, -1, 0, 1, 2, 3. What if your answer is 1/2? What if your answer, like we got in one there, was -7/2? It's not going to show up in this table of values, right? That would be a problem. So here's another way. This is going to get into a little bit of the complicated calculator function, but the calculator will find any 0 for you. Exactly, right? Even if it's the square root of 2, it'll find it for you. It'll give you the decimal value, but it'll find it, right? So with your calculator right now, hit second trace, right? It'll look like this. Let me put this in because I don't have this in here yet. Oh, I do have it in there. So you go second trace, and I'm trying to get this thing done. Let me have both, okay? I cannot figure that one out. Okay, so close. Sometimes it'll let me like scoot it over here, and sometimes it wants it to go back where it was. See, it's still going to try to go back. Okay. So second trace, and you see this menu. Number 2 is a 0, okay? 0 means x-intercepts. So if I hit 2, right, it shows your graph, and it's asking you a series of questions, right? The first question, when it says left bound, what it's asking for is an x value which is less than, to the left of, the 0 that you see. So you have to do this for each individual 0. Let's say I wanted to look at the one that I know is -1, but let's say I didn't know it was -1, okay? I need to put in an x value which is less than that. So you got two options. You could either just enter an x value, or you could use your arrow key to just move the cursor to the left. Watch my cursor go. See that? It went above the axis and a little bit to the left. So that's what the calculator is looking for when it says left bound. So I hit enter. Okay, now it says right bound. So I want to put in an x value which is to the right of that 0. So I move my cursor a little bit to the down and to the right. Okay, that works. And then when it says guess, you say okay, enter. And it jumps right to the 0, -1. Try to, if you got it, or even not, let's do it again. Let's try to find the 0, which was 3. We know it's 3, but let's use the process and let the calculator tell us it's 3. Okay, so we'll go second trace 2. Right? I need a left bound for this 0 right here. Okay, so let me move the cursor so it's closer to that 0. Oh, come on. Okay, is that to the left of the 0?
Yeah.
Looks pretty good. So let's go yes, enter. Okay, then I need a right bound, so let's move it to the right of the 0. Okay, that look good? It's up and to the right. So I hit enter. And when it says guess, literally what it's saying is, when you hit left bound and right bound, you put these 2 triangles on the graph. It's saying, are you okay with those triangles? Do you want to guess in between those? Yes. I mean, if you're happy with what you did, then you say yes. And it should jump to the 0. 3. So if you have one that's not in the table of values already, you know, this is a way to get the ones that are in between. But again, you're going to have to know a few steps to do it. Okay. Okay. If the zeros are fractions, they're going to be hard to estimate from the graph, so they won't show up in the table of values, so then we use that third process to do it. Sometimes you can guess. You know, if you see it looks like it's halfway in between, you might guess that it's a half. And then you could check, you know, just plug it in the original equation, see if it works. Most of them you won't have to do that. Okay, so let's solve by graphing. What was the first step to solve by graphing? Say again? No. Sarah? You got to have a 0 up there, right? It needs to be y equal, or 0 equals something. So how could I turn this, the 2? You could, so he says subtract x squared. Okay, that would give you 0 equals negative x squared plus 2x. What if you subtracted the 2x? X squared minus 2x. Okay, well let's see what happens if we do that. We've got 2 different parabolas there, right? Okay, what's the next step? We'll do the one on the left. What's the next step? Go to the calculator. Y equals, clear, negative x squared plus 2x. You could just hit graph. Okay, the first option was just look at the graph. Does it look good? There's a parabola. How many x-intercepts do you see?
Yeah, mine's down, but it's like...
Okay. So if you did this one over here, then your parabola goes up. If you did this one here, your parabola goes down. But the zeros are the same. So for the purpose of solving our equation, it doesn't matter which way it goes, right? This one goes down because it has a negative in front of the x squared. That's what makes a parabola open down. Right? This one goes up because it's positive. But that's why it doesn't matter which side of the equation you want to move them to. In fact, let me do watch, I'm going to go on the second line on y2. Let me put the other one, x squared minus 2x. X squared minus 2x. And graph. So there's the one that goes up and the one that goes down, but you can see where they intersect right at the zeros, 0 and 2. So the answers are x equals 0, x equals 2. Okay. Now you could have gone to the table of values, right? Second graph. And let's see, when y is 0, when x is 0, y is 0, when x is 2. So there's the 2 answers. That works. Okay, let's try another one. You try. Solve this one by graphing. It's already got a 0 on one side. See if you could get it. Right? So, y equals, clear, x squared minus 6x plus 8. graph. And it looks like there's two x-intercepts, 2 and 4, right? So the answers are 2 and 4. Okay, if I go to the table of values, second graph, you know, when y is 0, right there, x is 2. When y is 0, x is 4. So either way, you get the same answers. Okay. So now let's see what happens with this one. First step, I need a 0. How am I going to make a 0 on one side?
Subtract 1.
Subtract 1, okay. Okay, put it in the calculator. Negative x squared. Let's see if I can get it again.
It's going down. The answer is 1.
Oh, man.
It barely goes over the thing.
Let's see if I can get it this way.
I got 1.
Okay, I can't get this thing to cooperate. X squared plus 2x minus 1. And you hit graph, and what do you see? How many x-intercepts do you see? It's actually only one x-intercept. So how many solutions do you have? 1. So, in fact, if I would have done, let's say that I would have done it like this, right? If I would have moved the x squared and the 2x to the other side, then I would have had x squared minus 2x plus 1 equals 0. And then that I can factor that pretty easily. That's x minus 1 squared. It's a perfect square trinomial. And what's the solution if it's x minus 1 squared equals 0? 1. So you don't have two factors, right? With perfect square trinomials, you don't have two factors. You just got 1 squared. So that's what it looks like on the graph, right? It'll look like it touches the x-axis, and then it goes back the same way it came. Okay? The next possibility, not there. Let's try this one. X squared minus 4x plus 7 equals 0. Right? Put it in the calculator. X squared well, that's why we're showing it. So you put that in and you look at the graph. And what do you see?
Oh, I got that too.
How many x-intercepts? How many x-intercepts do you see?
None.
None. No solutions.
The other side. This Callahan, this is fun and
What's-
easy.
Okay.
Mine
So
is on the other side of the Y.
does it cross the x-axis?
No.
No solution. Did you have everything negative then? Like negative x squared plus 4x minus 7? Yeah. So doesn't cross x-axis.
Yes.
No solution. Okay? So try that one. Solve by graphing. Okay, so x squared plus x plus 1. Ah, wrong place. Clear. X squared plus x plus 1. Graph. And it comes close, but it doesn't quite touch. So there's no solution, right? And don't say 0. 0 is a solution. We had that on a previous problem. That's just, that's the origin. That's a good solution. So no solution. Okay, try this one. All right, so put it in the make a 0 on one side. Put that in the calculator and then hit graph. And it's one of these, that's a perfect square trinomial. So that means that it's one factor squared, so it only has one 0, right? Again, 0 means x-intercept. Okay, so when it says, so now we don't have an equation to solve, but it's essentially asking you the same thing. It's saying find the zeros of the function, which is like saying find the x-intercepts of the graph, find the solutions to the equation. All those mean the same thing. So find the zeros just mean, one thing you won't have to worry about, since it's f of x equal, there's not going to be a 0 on one side because it's got an f of x on one side. Do you have a question?
I'm gonna sharpen my pencil. Sharpen pencil brain. Woo! I don't know how.
Okay.
I sharpen my pencil.
Sure. So again, if it's still, as far as your procedures, it's just put it at y equals x squared plus 6x minus 7. Enter, and then you hit graph. And by zeros, we mean x-intercepts. And what can you estimate what they are? Is it -7 and 1? How could you make sure? How could you make sure? Go to the table. Let's go to the table. So definitely at 1, at x equals 1, y equals 0. So there's one answer. And at x equals -7, y equals 0. So your two answers are -7.
Is it f of x equals that? Or just
No, x equals. Look at graph for x-intercepts. And it's x equals 1 and -7. Okay, so you try. Find the zeros. Do you get a graph that looks something like that?
Yes.
yeah.
What are the solutions? Or what are the zeros? -3 and 2. Okay. Okay. Find the zeros. So now watch when I put this one in. Okay? This is for me. X squared plus 4x plus 1. All right, I hit the graph. And how many solutions do you see? 2. And what does it look like that they're at?
0 and -4.
So they look like they're at 0 and -4. So how can I confirm? Go to the table, right? So I go to the table and I look at -4. Do you see what's there? At -4, y equals 1. At -3, y equals -2. There's no 0.
That's crazy.
Okay? But you could tell that if y was positive at -4 and negative at -3, somewhere in between, it crossed the x-axis. So we didn't find it exactly. Let's go to the other one we thought was 0 or 1. And again, at -1, y is -2. At 0, y is 1. But there's no 0. So this is where you need the third process, because it's not going to show up in this table of values. So remember this one, right? Second trace 2 2 for 0. And now I'm going to have to go 1, 0 at a time. So let's get the one on the left that looks like it's around -4. So let's move the cursor to the left. Okay, is that good to the left?
I don't know. I know, but I think I need it. Oh, there's one.
So move it a little bit to the left, right there. Hit enter. Okay, now we need to move it a little bit to the right of that same 0. Okay, now it's down and a little bit to the right, so I hit enter. And if I'm okay where I just put those 2 triangles above the graph, I hit enter. And it jumps to the 0. What is the value of the 0?
Oh, -3.
Negative 3.73. So
I did different ones.
you got the wrong answer. Okay, the answer is negative 3.73. Exactly. Okay, what did you do?
Oh,
That's a different problem. Okay, now we got to find the second 0. We found the one that was near -4. Now we got to find the one that's near 0. So let me go second trace 2. For the left bound, I'll scoot it over so it's a little closer to that 0. It's still to the left though. Enter. Then I'll scoot it to the right, above and to the right. Enter. And then I hit enter. And it looks like it's negative 0.27. So those kind of values are not going to show up in a table of values, right? You just have to get it with the calculator.
you should do more.
No, we don't have enough time to do that. So just remember, this is important. This is like one of the main learning points here. When you solve an equation, those are called the roots of the equation. They're also the solutions to the equation, obviously, because that's what you got when you solved it. They're also the x-intercepts of the graph of the function, which are also known as zeros. And, those things all have, really kind of a precise meaning, but we kind of use them interchangeably in a way it's kind of sloppy sometimes. Whatever you hear, if somebody says find the roots, it means find the solutions, right? So just keep in mind all these words when you see them are really referring to the same thing. Somebody shouldn't say find the zeros of an equation. That doesn't make sense. It should be the roots of the equation, the zeros of the function. But if they do, it just means the same thing.
This is actually really fun.
Okay?
That's not a lot of money.
Well, so we're going to take a quiz now. I hope it takes you about 15 minutes and maybe about 15 minutes or so to work on this with the calculator in class. We'll spend some time at the beginning of next class doing the same thing because you need the calculator. Okay, okie dokie.